All right, what's up, dudes? Welcome to another vlog. Long time no see. I haven't posted anything on YouTube in a minute. Mike Van Schellenbeck here. We're obviously, during this whole quarantine thing, really not supposed to go out and do stuff, so I've been staying at home. But today I'm going to be pulling apart an M50TU Vanos engine. I'm putting one together for my buddy Tyler to put in his E30 because he's just had constant issues with his M20 with the head and the timing belt and everything. So I have an M50TU behind me, and I'm going to be pulling at least the head off of it tonight and taking a look at it. Don't have an engine stand here yet, but I will tomorrow. We're going to be doing, this is actually the 2.5 liter M50 out of my red sedan. As you guys remember, I was building a budget setup for that. Decided to nix the plan, a whole lot of reasons, put in my built engine, but this engine's still gonna get turboed and go in Tyler's E30. So let's take a look at it and I'll explain what we're gonna do. All right, so no engine stand here. I just got some junk tires and set it down on the garage floor for now. I'm basically gonna pull the valve cover off and the head, cams, and look at the pistons. And then we're gonna take the head to the machine shop to be resurfaced for a new head gasket and pressure check all the valves to make sure they're not leaking or anything. And then I'm going to put the engine on a stand and check out the bearings in the bottom end, make sure they all look good. We're trying to do a very budget build on this thing, so I'm not going to be fully disassembling it and sending it to the machine shop for machine work. We're just going to hand clean up the block deck a bit. We'll have the head itself professionally surfaced. Of course, you want a good head gasket seal, so you do that. And the rotating assembly is just going to be a stock 2.5 liter stock rings. Not going to pull any of that apart, just to keep it very simple for Tyler. He only wants about 400 horsepower, which is no problem to make on a completely stock rotating assembly without regapping the rings larger. So yeah, that's what we've got. Trying to think what else to talk about here. I'm just actually getting distracted because I'm noticing there's a bolt in the back of this head. Oh, I'm stupid. The port's right here for the heater. It's like, where the hell is the port? But that's actually a different flush out port. Never mind. So yeah, let's get to it. All right, so first thing to do is pull the ignition, the coil packs, spark plugs, and the valve cover. Those are all 10 millimeters. You have to be careful because some of these can pull out of the head, the studs, but I mean, gotta remove it regardless. So 10 mil there, and then 13 mil on the valve cover bolts, and we'll pull that off and take a look at the cams. Let's do that right now. Alrighty, I removed all the ignition. I misspoke earlier, they're all 10 millimeters, including the valve cover, not 13. So now we should be able to pull this thing off. I did not pull the plugs out because I don't have a plug socket over here at my girlfriend's house. Very minimal tools. But looks like it came right off. Let's see what it looks like. I'm gonna put this down and pull that cam cover. Good. Alrighty, got the valve cover off and the gasket off. The gasket was quite crusty, as to be expected, since it's 25 years old or so. This is a 1994 BMW M50TU. TU stands for Technical Update, which means it has Vanos. You can tell if it's a Vanos or not by this hump right here on the front of the valve cover. If it's completely flat, then it either didn't come with Vanos or the person has deleted it. I don't know why people delete Vanos, because it's incredible for torque, and you really should keep it, but a lot of people just don't want to mess with it, and they go ahead and just run locked cams, so they delete the Vanos. I don't recommend that. I think you can get way better power band keeping it. So anyways, we've got, this thing has 176,000 miles on it, and as you can see on the exhaust cam, it looks really good. A light polish on this thing. There's absolutely no grooves in any of the lobes. You could just see tiny little wear marks, but that's 176,000 miles of normal wear. There's no grooves, nothing catches the finger at all, which would indicate a problem or damage from debris in there. And if we pop off the intake cam cover, by the way, for those of you who have ever put one of these together before, when you're putting it back together, make sure to reinstall this plastic cover. It's an oil slosh preventing thing. And on the valve cover right up here near the intake cam, there's a port for the crankcase ventilation. And if you don't have this plastic cover back on there, you basically just sling oil off the cam right out the valve cover. And it looks like you have blow by, but really you just forgot to put that thing on. So don't forget that, don't break it. I'm sure they're stupid expensive, but they usually don't really break. And now we can see the intake cam. And it looks excellent as well, which means this engine probably has had good oil changes and not any debris or bearing problems. These things basically never have bearing problems. Anyway, they have a very good oiling system and flow a lot of oil to all the journals. But, you know, it's still something that can occur if you didn't change the oil enough or just happen to have a piece of debris for whatever reason in the engine, some type of metal or something that's a foreign object. So anyways, that's very good. Now we're going to work on pulling off the vanos up front and then pulling the cams out. That way all the valves will close and we can get to all the head bolts, pull the head off, and then we'll strip the head and take it to the machine shop to be resurfaced. You want to have a nice smooth finish on the bottom side of the head where it meets the block. That way you get a good head gasket seal. So let's get to it. All right, well the cams look really good. I don't know if I already mentioned that in the prior clip or not, but it looks like it hasn't had any debris or anything in it. All the lobes look just fantastic. We'll also pop a cap off. We're gonna see inside the cam journals here shortly when I pull the cams. So next step before we do that is to pull off the thermostat housing and thermostat, water pump, crank sensor, and this engine hoist bracket, and then we can get to all the Vanos stuff in the front cover. Get the Vanos off, and then pull the cams out, and then the head off. So let's get to the water pump and this stuff right now. All right, well, we think it had good oil changes, but I don't think they maintained the cooling system all that well just by all this crusty junk in here. The thermostat's actually stuck in there, and there's a whole bunch of crusty crap inside the thermostat housing. So luckily it's already an aluminum one, which is good because some of them are plastic and they'll crack. So the upgrade is the aluminum one. We already have that. But this is not that good. It's not terrible because you don't see like a whole bunch of rust and porosity deep in the cylinder head, but just at the surface. But basically this indicates that someone didn't use enough coolant and didn't flush it properly over the years. You basically want to flush your coolant once every, I think like 2 years is the recommendation, but you know, essentially the anti-corrosive properties of the coolant degrade over time. And if you don't change it after that's degraded, then you just end up with corrosion occurring. Even though it's an aluminum cylinder head, it can definitely corrode and oxidize and all sorts of stuff. So we'll see the extent of the passages and flush all that out at the machine shop. It'll be good as new. But yeah, change your coolant, guys. Flush your coolant. That's why. All right, so thermostat housing's off, water pump pulley's off, got the belt off, and now we have to pull out the water pump. I've removed the 4 nuts. There's just studs on the front timing cover there, and it's stuck. It won't come off. So the trick is BMW has these little holes right here where you can thread in a 6mm bolt. So I'm using 2 of the bolts from the thermostat housing, and you basically just thread these in, and it pushes. It's threaded on the water pump, and it just pushes on the timing cover behind it. So as you torque them down, oh, there's a spider there. Oh, it scared me. It's a dead one. Who cares? But I care, I guess. One sec. Let me find that bolt. All right, spider removed, bolt required. So basically, you just turn these guys in until they stop, and then a little bit of pressure beyond that essentially just forces the cover or the water pump out. So let's screw this in a bit, see if it'll start separating. This one hasn't touched the back yet, obviously. This side. And you can actually, I don't know if you guys can see that on the camera here, but it's very slowly eking water pump forward. And since this cooling system looks like it really hasn't been flushed well, I'm guessing this is pretty well seized in there. You can also tap it with a rubber mallet at this point to try to break it free. I might do that. Let's see if I can just whack it a little bit here. Nope, nothing yet. It's in there real good. I thought we were gonna get lucky with this engine being like perfectly maintained and shit, but can't win them all. Definitely tight coming out. We're almost there. Oh, Jesus Christ, that is impressive. What is the water pump gasket just holding it at this point? That's crazy. All right, to be continued. It'll pop off in a sec. All right, finally got it out. Made a little bit of a mess because I forgot there's coolant in it. I thought I drained everything, but apparently did not drain the block. So the inside here definitely needs to be cleaned up. That's the front timing cover area. Tyler has chosen to keep the stock rotating assembly in the bottom end unless we find something like catastrophic that needs attention. So I probably won't be removing this. I'll do my best to clean it up right here, and then we'll have all the head will go to the machine shop and be totally flushed and everything. So should be okay there. I'll just clean up the timing cover there as best I can. And next step, we need to remove the crank sensor here with this Allen bolt, and then start removing all the Vanos stuff up front there. So let's get to that now. One more thing I forgot to mention. This is a plastic impeller water pump. So let's put some light on it here. So this piece is what actually moves the water. You see it's got those paddles in it and it spins. And these are not the one you want. You want a metal impeller. So the aftermarket water pumps, you can get them with a metal impeller, and those are much more robust and won't crack up over time. Surprisingly, this one's looking okay. But you don't want to take a chance with a plastic impeller or water pump on these things. So get a metal one. And back to it. Alrighty, well, I removed all the external bolts for the Vanos. Pretty much ready to pull that off the front. Pushed down this tensioner and locked it. There's a little hole back here to slide a Allen wrench through, so you can just push it down and lock it to get a little slack on this chain. And then you have to loosen these Torx bolts and then rotate both cams clockwise as you pull the Vanos out. And there's a special tool that actually grabs the teeth of the exhaust cam here, or the front part of the exhaust cam gear. And I have one, it's just not here. So basically I'm kind of at a stopping point. It's very difficult to get this to rotate without that special tool because there's really not access to like pry anything, or I don't want to fuck anything up either. So probably go get the tool. I'm just feeling a little bit lazy, but you know, 20-minute drive, whatever, 30-minute drive, go get it, and then get the Vanos off. Once the Vanos is off, pretty much disconnect the cam gears from the cams, get the timing chain off of them, and then slowly remove all the cam caps. So BMW inline sixes, the M50 series, M50, M52, S50, and S52 all have hollow cams. And that's for lightweight, it's better for performance and valve train stuff, but you have to be very careful when removing them because they can't take a lot of torque. So you have to be conscious of whatever lobe is pointed down, like that number 6 is pointed up, it's not pushing on anything, but number 5 is pointed down. So that means that it's pushing on the valve spring and has quite a bit of upward pressure, coincidentally, on the cam, you know, forces equal or whatever. And so if you loosen all the caps around it and keep that one tight, or vice versa, loosen the wrong one, and it basically has a whole bunch of upward pressure where it's not being supported otherwise, you can snap one in half. So essentially you just loosen like a quarter of a turn at a time and tap it with a rubber mallet the entire time just to keep it free, and then they'll just come up easily. So I think I'm gonna go grab that cam tool, cam wrench turning thingy, so I can get the Vanos off and continue, because I really want to get the head off tonight and look at the pistons and see a little bit more into the internals of this thing. So that's where we're at right now. I actually didn't remove the cam sensor because I realized the timing cover is going to stay on for now. Tyler's decided to keep this pretty budget oriented, so we are trying to do as much as we can with a small amount of money, which basically involves ARPs, cut ring, copper spacer, head gasket to lower compression because he wants to run pump gas, and weld the oil pump nuts so it doesn't die on the limiter, and baffle it so it has good oiling all the time. Even though these things are pretty good about that, they're rear sump, so when you're on throttle, all of the oil is held at the back anyway, and that's where the oil pickup is. So I can't remember if you have to go front sump on A30s or not though. That would be something to consider before we do the baffles. We'll have to talk with Tyler about that. But to be continued. Another quick note, guys, I keep having random epiphanies while I'm working on this thing or sitting here thinking about next steps. And if you ever buy a used M50 or any used engine for that matter, one of the best ways you can check the health of it immediately overall, as far as like bearings and stuff goes, is to look at the oil filter. So on M50s, they have this metal oil filter housing, and it's a cartridge style paper filter that just drops in there. So this single 13mm bolt cap comes off, you pull the filter out, and the filter filters from outside in. So you just look at the outside flaps of the filter and look for metal. And if you don't see any metal, chances are your engine is still totally healthy. A tiny bit of metallic particles here and there are normal-ish. If you ingest a bunch of debris or you're beating the crap out of your engine like we do with drifting, you might see a little bit of debris over time, but you should not see any substantial amount of particles in there at all. So tiny bit's okay, a ton is bad. And so the quickest way to check the health, like I said, pop out that oil filter and take a look. So we're gonna do that here shortly, just to kind of get a reference point. Alrighty guys, what's up? Welcome back. Last I checked in, was feeling lazy, didn't want to go get this tool I needed for the Vanos. Decided to be unlazy and go get it. So I got the Vanos rotating tool for the exhaust cam, as well as the valve spring compressor I need to strip the head to take it to the machine shop. So now we should be able to pull the Vanos off, pull the cams out, and then pull the head off totally and take a look at what the bottom end looks like, what the top of the pistons look like. I'm assuming they're all, you know, tons of carbon on them, like everything with 176,000 miles. But we also want to inspect the cylinder walls and make sure they're not really scored up or anything weird. We just want to make sure the factory cross-hatching, it's called cross-hatching, right? Yeah, cross-hatching of the honing process is apparent. So when you look on the, when you hone a cylinder, the honing procedure is done in one direction and then also in a 90-degree opposite direction. So you can see this X that's created in the cylinder. And if you can't see that, that means that it's worn down quite a bit. But if you still can see it, that's a good sign. That means that it hasn't worn that much. So basically, being able to see the factory cross-hatching is a great thing. I apologize for the lighting and everything else. It's like 11:30 at night right now, and I'm just doing this because I can't sleep yet. Quarantine things, my schedule's all screwed up. So anyways, you want to see that factory cross-hatching, so we're going to look for that just to make sure the cylinders look like they're in good shape. Because like I said in a prior clip, Tyler does not want to spend a lot of money on this thing. Total budget for this entire engine, including the engine, is about $2,500. So I gave him a deal. I sold him the M50 TU Vanos, a technical update. So Vanos engine, and the M50 TU means M50 Vanos. I sold it to him for $500. I feel like that's a pretty fair price considering there's nothing wrong with it. It seems like a good rotating assembly. It's kind of how much they go for on eBay, and I'm local. I'm able to give it to him right now. So, and I'm helping him out with the rest of the stuff, right? So fair price. You know, maybe you can find one locally to you for a little bit less than that. Don't give me a hard time on that. That's, you know, if you can find a junkyard one for $300 that's rusted to shit, I really don't care. This one's a good one, it's $500, okay? So that aside, $500 for the M50. And then we're just doing basic stuff to it. So we're gonna do ARPs, a copper head gasket spacer, so that just lifts the head a little bit and it lowers the compression ratio of the pistons effectively. So stock compression ratio is 10.5 to 1. For boost, you usually want to run a little bit lower compression ratio so you can run more boost effectively, and that allows you to just make more total power for any given octane, because we can get really technical with that, but the long story short is when you compress air, which you're doing with a turbocharger, or compression in the engine, you heat it, right? So if you compress the air, you heat it a bunch, but then with the turbo, you have the opportunity to intercool it and cool it after you heat it. So you basically have compressed all this air, created a massive amount of airflow to get into the engine, but it's really hot, it's not good for power, so then you cool it back down and you blow a crap load of cold-ish air into the engine, and that makes way more power. Versus if you just have higher compression or something and you're not like using boost to make your power, if you have higher compression but less boost, essentially the compression happening in the engine in just a normal combustion cycle or whatever cannot be intercooled after that. So, 11.5 to 1 compression is going to make more heat in any given cycle of the piston moving up and down, whatever, any given power cycle than a 9 to 1 or 8.5 to 1 engine. So essentially the engine runs cooler with lower compression, with lower static compression. Your effective compression is an equation that relates your static compression of your piston and just the physical geometry of your engine plus boost pressure. So what you really care about is effective compression ratio, and that can be really, really high with boost and still be safe. So if you're octane limited, it is better to run lower compression ratio static, aka the pistons and all that geometry, and then just a lot more boost. So like an 8 to 1 or 8.5 to 1 engine is going to be able to make more total power on pump gas than, let's say, a 10 to 1, 11 to 1, anything like that, because you can run a lot less, or you can run a lot more boost on the lower compression engine, and you have the ability to intercool it or cool it after the compression takes place, versus with the higher compression engine, you can't do that. It's already in the cylinder. It's hot, it's just not gonna work. So there's no way to after cool it beyond that point. Anyways, efficiencies aside, low compression is better for pump gas. That was a really long tangent on that, but I just felt like that should be explained. I've never talked about it on a video. So back to Tyler's engine. We're doing spacer, copper cut ring spacer from CES Motorsport for lower compression, because the stock compression ratio, there we go, it's 10.5 to 1. And adding this spacer brings it down to about 8.5 or 9 to 1, something like that, much more turbo friendly, so we can run some more boost. With the stock ratio at like 10.5, you can only run 8 or 10 PSI safely on like a medium sized turbo. And with the lower compression ratio with the spacer, you can run more like 15 to 18 PSI on 93. So it's a lot better, a lot more power available there. But yeah, let's stop staring at me and stare at the engine maybe while I talk instead. All right, so basically at this point, I have the Vanos tools. Let's see. This wrench here, let's see what the part number is. BMW 3044 special tool. I'm lucky enough that my dad actually purchased this because he got into turbo M50s and stuff just like I did. But basically what you do with this thing is this little indent goes into a opening in the teeth on the exhaust cam here, and you rotate the cam using this tool. So you lock that in, that pin goes into one of the little openings here, and then you rotate that clockwise while pulling the Vanos outwards. So I've already removed all the bolts, but it's stuck due to the spline shaft in the intake cam over here. That's how the Vanos attaches. There's just a spline shaft attached to this unit that has to come out of the front of the cam. So you basically rotate this clockwise while pulling this forward. And I'm gonna do that now. And I apologize, I can't film active procedures like that. I'm gonna be fixing that in the very near future. I'm gonna get a GoPro helmet strap, essentially, or not helmet, but head strap to put on my head. And I'll look like a goofball, but that won't matter. You guys will be able to see live what I'm actually doing versus me just saying, hey, here's what I'm about to do, cut the clip, I do it, come back, it's done. You know, a little bit more immersive for these vlogs. Not that I'm like trying to pursue vlogging a bunch or anything, but I feel like anyone, if you're getting any kind of benefit from these videos, I would like to improve your experience. Let me know in the comments below, please. Let me know if you watch this stuff and you're actually legitimately trying to learn. I'd be happy to help continue making these videos, but I really am not doing it for any type of monetization or anything like that. So if it helps you, I'll do it, but you gotta tell me. So yeah, let's get the vanos off now, and then we'll be able to pull the cams out and loosen all the head bolts. You basically, when you loosen the head bolts, there's 14 of them. You do it in a reverse procedure of torquing. So I can't remember exactly what the procedure is, but it's basically outward in. So it's like this, and then crossways, and then something like that. You know, they just kind of alternate essentially, so you don't tweak the head in any given direction. Stock head bolts aren't that strong. They're only torqued to like 60 foot-pounds or something like that. So it's not like it's gonna tweak it if you did loosen it in the wrong order. But that is something to be aware of on these things. 6-cylinder inline head is long, and they can deform over their length. So be nice to them, torque them properly. And let's get to it. All right, we got it out. So it just took some wiggling, rotating the vanos on the exhaust cam gear clockwise using this tool, and now the vanos unit is off. I just had to wiggle it off, and so now you can see this set of gears, which we have to remove. This tensioner has already been compressed with the Allen, and the Allen key's in there holding it down. So we're gonna remove these 3 10mm bolts. These are all loose as well. We'll pull that pair of gears off. There's some spring plates and things in here that will come off as well. And then we'll basically have the cams free, except the exhaust cam will still have the timing chain on it. I've already removed the timing chain tensioner from down on the side of the head on the lower side. And basically we'll be almost ready to remove the cams entirely. So we have to take these gears off, take this chain off that links the 2 cams, and then remove this gear to be able to remove the exhaust cam fully with this timing chain not interfering. And like I said in a prior clip, we're gonna have to loosen all of the cam caps about 1/4 of a turn at a time. These are, I think, 11mm? I can't really remember actually. There are 10 or 11mm, maybe 10s. But either way, you basically take each one, there's two per tower, all the way down, and you just move them 90 degrees at a time. So 90 degrees, 90 degrees, next one, 90 degrees, 90 degrees. Go all the way down and repeat, and just keep going, and slowly the cams will rise up from the spring pressure of the valve springs underneath, and then they're free. So you just have to be very conscious of this because the cams are hollow, and if you put too much pressure at any given point and it's not supported nearby, like say this lobe was pressurized and pushing down really hard and these were free, then you would have a big upward force here and nothing holding it here, or maybe it was holding it here, holding it here with the bearing cap rather, but pushing this way, you can snap the cam. So you essentially just need to remove them and tighten them in a very smooth and careful order to make sure it's like sitting down flat when you're installing and removing flat when you're uninstalling. So that's that. Let's get to it. We'll remove this front set of gears for the vanos, and then we'll remove the exhaust cam gear that runs the timing chain, and then we will remove the cams, and then the head finally, and take a look at the pistons. Here we go. Alright guys, I feel like there's a lot of videos on BMW M50 engine disassembly, and this is kind of repetitive because if you're somewhat car savvy, you've probably already searched on YouTube and know how to do this stuff. If you're not car savvy and you just happen to come up on my channel and you want to see the whole thing, well, I'm going to try to film each individual step for completeness, I guess. So we're going to keep showing each step in the disassembly here that we're doing to make this a turbo M50 budget build. And just now we've removed the vanos. I said in just a prior clip that I was going to get a GoPro head mount so that I can show you this stuff with no interruption in live form. But I don't have that yet, so I will be purchasing that and get it in a couple days. But anyways, we've compressed this tensioner and put a Allen through it here. You can see this is just an Allen wrench going through. There's a little hole in this piece here, designed to basically compress this tensioner to slacken the chain between the two cams. So the timing chain that runs off the crank runs the exhaust cam only, and there's a tensioner over here in the head that tensions that, blah, blah, blah. But the intake cam is turned by a separate chain, which is on these two gears here that I just removed. This piece goes in here. There's some slotted holes here for vanos stuff. But basically, the exhaust cam is turned by the timing chain, and then the intake cam is turned by the exhaust cam via this chain. So we have that removed now. And the next step is to remove this tensioner, which is a 10 millimeter here, a couple 10s there, and I think that's it. It will come right out. Those typically don't go bad. Like, you can replace that if you're being very, very thorough and doing a full engine build, but we're doing a very budget build here. So we're gonna inspect this thing, look at it a little bit, but it most likely is just going back in as is. This engine has 176,000 miles, like I mentioned prior, but all the cams look really, really good. We'll see what the bearings look like. We are gonna be pulling the oil pan off, switching to a front sump oil pan because this is going in an E30, and M5X engines, if you want to call them that, which I'm referring to M5X as M50, M52, S50, S52. Essentially any BMW 6-cylinder from 1992 to 1999 is this basic engine. Okay, they're all slight differences, but they pretty much all Lego together. So M5X engines, what was I saying on that? I don't know. I'm just showing you how to pull it apart and how to get it ready for turbo. So we're running the stock bottom end, 140 millimeter rods, 10.5 to 1 compression, but we're lowering the compression with a copper head gasket spacer to about 9 to 1. We're gonna run 15 pounds of boost-ish, and undecided on turbo, but most likely a mid 50 millimeter turbo, so around 55 millimeter compressor or less to suit the 2.5 liters and 9 to 1 compression. So anyways, getting back to pulling this thing apart, we've got the gears off. We're gonna remove this tensioner. We're gonna remove this gear totally, which basically can already pull off because I've already pulled the Torx off of it. Just need to get the tensioner out of the way. And then this will pull forward, come off the cam, and then I can take the chain off of that, put the gear aside, secure the chain over to the side of the head or somewhere. It doesn't really matter actually because it can't come off of the crank, which is what you're mainly worried about here. So when you pull the timing chain off of the exhaust cam and it's just free to like be held over here or whatever, some people think, oh well, you don't want to let it like fall too far because then maybe you would have a link come off of one link of the crank gear and something would get fucked up down there. So when you put it back, it won't be right. But there's actually a little pin thing that kind of holds it like right next to the crank gear so it can't come off down there unless you basically remove the oil pump. So it should be good. I hope I'm not wrong on that. It's been a while since I've had the pan off on one of these things, but I'm pretty sure that's how it works. But yeah, we're gonna get this tensioner off, get the exhaust cam gear off, and then we're gonna slowly pull the cams out. I'll probably have a little bit more clips in between before doing that to show you about pulling the cams. But I already mentioned you just do it quarter turn at a time, 90 degrees, 90 degrees, 90 degrees, keep going down the line of the cam, line of the cam, and then just repeat. And you're only worried about the journals that have the cam lobes pushing down, right? So this one, as you can see, number one right now, is the point is over here. That's what actually opens the valve, and it's not pushing downwards on the lifter, which is completely underneath here. You can't see it. So if it were to be rotated this way, it would be pushing that valve open, and there would be pressure on the cam. But as we can see here, since the lobe is to the side and not at the bottom, pushing downwards on the valve retainer and valve spring and then valve, then we know that there's no pressure on this one. So this journal effectively is going to be no pressure because there's no upward force from here, okay? Same thing here. You can see the lobes not pointing downwards, not pushing on the lifters. This one has pressure for sure because you cannot see the point of the valve, sorry, the camshaft lobe on either side, which means it's most likely pointed down either in this direction, this way, a little bit, but it's pointed down, which means that it's pushing on the top of the valve retainer. Haha, I got you. And then the valve spring and lifter, and then basically pushing the valve open. So that means there's going to be a lot more pressure on this valve cam cap than this one or this one or this one. So you need to be leery. That's a good word my girlfriend taught me lately. Leery. You need to be leery of this cap when you're removing it. This one, as you can see, the points are up, no pressure. This one, points are down. So, but they're down and to the side, so they actually may not have pressed on the lobe yet, so they may actually also be no pressure. And typically there's a position you can rotate the engine or rotate the cams to where basically only one or two have significant pressure. And as long as you loosen them all carefully and you just like lightly tap the cam and the cam caps with a rubber mallet as you're doing it, it should not bind up and it should be free and just come up like smoothly and not really be an issue. It's only an issue when you're just like ignorant about this and you don't know that there's hollow and you just like start removing everything. Let's get the cams out. Fucking who's got the Milwaukee? Give me my fucking M18 fuel. Let me blast these bitches off. No, don't do that. Just take it slow and you'll be fine. So we're gonna do that now. I will pull the tensioner off, like I said, pull the gear off because it's already loose. Just the tensioner is blocking it from coming forward. And then we'll pull the cams out. Then we'll be able to get to all the head bolts, which there are 14 of them as well. And there are Torx stocks, which I have some Torx sockets with me here. Perfect, so I think it's an E12. I'm pretty sure this is a 12, but either way, we've got the right socket for that. We'll pull those off and then pull the head off and take a look at the underneath. I'll inspect the cylinder walls and better know what the condition of Tyler's engine is here. So let's go from there. Wow, that was a long clip, 9 minutes, Jesus. All right guys, got the upper tensioner off there, the one that sits here. And next step is to remove this gear, which has the timing chain on it, like I said earlier, but you have to remove this timing chain guide because it holds it forward. So there's a couple Torx sockets here. Let's see, one there. And then I thought there was another one back here. Maybe you have to remove the cams before you do that. Let's see if we can wiggle it off without doing that. Oh yeah, okay. Actually, I lied. So the gear is off, cam is free. We'll get both the cams out now, and then we should be able to remove this guide. But basically we have to strip the head entirely right to get it to the machine shop to make it as minimal effort and as cheap as possible for Tyler to do this budget build. So basically I want to strip the head, have them just deck it, and then I will actually reinstall the valves myself, valves and valve springs. I'll have them all tested just to make sure they're not like blow open and valve float at 300 wheel or something, but typically they don't do that. But we do have the tools to do a valve spring compression check, essentially, to make sure all the valve springs are okay. And he only wants 400 wheels, so it's not asking all that much, but we want to make sure it doesn't float the valves. And, because that could cause plenty of other issues, especially at high RPM. Floating the valves on an interference engine, not always a good idea. If you're lucky, you just have a lack of power and it just starts blowing out the power. But if you're unlucky and it floats them too badly, then you have a valve hanging down when the piston's coming up, and you have an interference event, and that basically can ruin the entire engine really quickly. So we want to not have that happen. So now that front tensioner is off between the cams that drives the intake cam, and the exhaust cam gear is off of the exhaust cam. Just rides on that part right there. So now we get to loosen all the cam caps slowly, like I mentioned. Hollow cams, just do it slowly and lift them up, and then we'll have access to all the head bolts very easily, and we'll get the head off and we'll be done for tonight. Alright guys, so we have all the cam caps free. They've all been removed in a slow order, quarter turn at a time, like I mentioned. I haven't actually taken any of them off yet, but they're all loose and free. So I'm going to take those off. Luckily they're marked, so you know which is which, and you can put it back in the corresponding cylinder. So let's see, for the example, this one, it's hard to see there, but it's marked, it's etched in E1. So E stands for a German word that actually means intake. So it's kind of confusing, but E means intake. This is the intake side of the head, so that makes sense. Intake cam 1. Then this one's marked E2 correspondingly. I don't know if it'll focus on that or not. I think you can see it there. Yeah, E2. So you can read them all in this direction too, so you know which direction they face rather than being 180 out. You read them this way. So you're looking at the engine, you're standing on the passenger side where it's canted over towards you, and you can see E1, E2, E3, all the way to 7. And then on the exhaust side, same thing. You read them from this direction, but they're A, A1, A2, A3. So in German, there's a German word that means exit. It's actually Ausfahrt, which is funny because it sounds like fart, but it starts with an A, and so that's exit. So it comes into the head, Eingang, or I don't know, there's probably some other like motorsport engine related word that means air intake, but enter is Eingang, so, or entry, which starts with an E. So makes sense, these are marked E, okay, Eingang, and then A, Ausfahrt, which is hilarious. We're farting out this way in a bunch of pulses. We're farting a lot, and starts with A. So now you know when you're taking one of these apart, you basically can't get them mixed up. You just pull them off. And let's see, this is the first one I've actually pulled apart, so I'm just as surprised as you guys. Let's see what's going on here, get some better light. Right under the garage light here. Come on, focus. So this is number 1 on the cam, and yeah, it looks absolutely perfect. There's very, very minimal, like you can see a couple lines at the top there, but that's just normal wear and tear of metal surfaces over 176,000 miles in 25 years. That is basically absolutely nothing, which means that the oil condition of this engine is probably very good, because the cams are one of the last thing oiled. So when you have the oil pump running, like when the engine's running, it sucks up oil from the oil pickup tube, which is in the pan, right? And then it goes into the oil pump, which is near the front of the engine, and then it fills the oil filter housing, which is this thing, okay? So it immediately picks up from the pickup tube, which has a filter strainer on it, and then goes into the oil filter housing to immediately be filtered again. So it's filtered, the screen, and then filtered again through the paper filter, goes through the filter, back into the engine, and then immediately goes to the main bearings. The main bearings are all oiled, and then the rod bearings are oiled. So basically the main bearings hit oil first, they hit oil pressure first, as the engine's building pressure, like when you first start it. The main bearings are oiled first, then the rod bearings, and as oil pumps up through the head from the oil pump, it oils the cams. So the cams are last, and so if you're gonna see any kind of damage from lack of oiling or poor oil changes or things like that, you might see it in the back of the cams, or like maybe in the back of the rod journals or main journals, anything at the back of the engine basically. But mainly the head, because the head is oiled theoretically last. It's the longest distance for all the oil passages to charge up and flow oil. So that's a very good sign. That looks like a very good bearing cap. Super shiny. They basically see no wear on this thing, which is crazy, crazy good for 176,000 miles. This also, I should mention, as you can see, there's torque converter here. This was out of an automatic car, and the guy had a sound system in it. So basically guaranteed that he wasn't a hot rodder, like revving it high or doing anything crazy. He was pretty much just cruising around in this thing, bumping his system. So chances are this engine is going to be very healthy. We will see. Stay tuned. Alrighty, I keep stopping at every juncture for sake of completeness of pulling apart a BMW M50, M5X, whatever you want to call it, S5X, a US-based inline 6-cylinder BMW from 1992 to 1999. This is applicable, okay? So we pulled off the Venos, pulled off all the cam tower caps just now. Everything is looking perfect. This engine has 176,000 miles, and if it will focus, even on the journals, I mean the lobes looked perfect, but even on the journals where it's actually getting oiled, filtered oil, and not just splash, this is all showing absolutely no wear, which is incredible. These things typically don't fail up here anyway. They're just like very robust and have good oiling systems, so there's not really an issue ever. What's that? That's just oil. So there's not really an issue ever. It's just, it's always refreshing to see when you pull apart one that like wasn't yours or was never owned by you, and you're like, oh man, this thing's actually absolutely perfect, like super good. So very happy with that. About to pull the cans out. They're actually completely free right now, as you can see, and the trays are free as well. So I'll be pulling all that apart in just a second, and then we'll pull the head off and take a look at the pistons. All right, guys, I can't remember what the exact last update was, but oh, low battery, great. Okay, so Vanos is off. We removed those gears and the chain, and I've also removed all the head bolts at this point. So they are an E12 torque socket for the factory. You're just gonna throw these away. Do not reuse them. They're not worth anything. They're all going in the trash, but they're an E12 Torx. So throw those away when you take them out. Go with ARP. Beyond that, so there's 14 of those. You can see them at these little polished looking surfaces where the washer is missing. Obviously that's where oil was not, because it's the surface of the stud, or the bolt rather. And then one last thing you have to get, I removed the exhaust cam gear. It was over the timing chain here. Just put it over there. So the chain is just chilling right now. Typically, if you're doing a head gasket, you might like care about keeping this held up or something, or making sure it's like not fucking up on the oil pump, but we're actually going to be removing the oil pan and the oil pump anyway, so none of that really matters. You'll be able to check that later. Reason being, you need to weld the oil pump nut to the oil pump gear on these things so that they don't vibrate off. They work really well on the limiter all the time at 7,000 RPMs, especially these, because these are very short stroke compared to the ones that have harmonic issues, mainly being the 3.2. So I'll try to make this a 30-second quick side note. On these engines from 1992 to 1999, some of them had harmonic issues at 7,400 RPMs. That's only on the 3.2 liter versions, which had the most strokes. So they have like an 86 millimeter stroke or 89 millimeter stroke. I can't really remember, but it's the most stroke of all the 6-cylinder engines, okay? And crankshafts go through, anything rotating really goes through what's called harmonics. And there's a certain RPM that it's rotating to where it gets wobbly, okay? And there's what's called a first harmonic, a second harmonic, third, fourth, and so on. And so basically, when you get to a certain RPM of the first harmonic of something rotating, it becomes wobbly at that harmonic. It does not like it. But if you increase the RPM more, it gets smooth again. It gets out of the range in which the weight and everything and the deflection of everything was problematic, and it becomes smooth again. So you just increase the RPM, it goes smooth again. Second harmonic is usually the problem for crankshafts. So on BMW inline sixes, the main problem on them is the S52 crankshafts, which are available in the US only. And they are 3.2 liters, and I can't remember the exact stroke length. It's less than an S54, which revs even higher. Talk about that later, but it's like, I think it's an 89 millimeter stroke. But anyways, they have a problem with second harmonic at 7,400 RPM. So if you hit 7,400 RPM on a stock rotating assembly S52, you possibly can have some issues with oil pumps breaking and dampers coming loose and things like that. The cranks pretty much never break, but that's a possibility based on harmonics, okay? So, that being said, with all the other inline sixes of every other displacement besides the 3.2, they do not have that issue pretty much. So a 3.0 crank out of a 95 M3 is good. That's what I run in my, it's what I ran in my coupe, but now I run in my sedan. It's an 86 millimeter stroke, and those things are very rev happy as well. You don't really have issues at 7,400 RPMs. Also, the harmonic thing is not really an issue if you blow through it. So, like, if you had an issue at 7,400 RPMs, that would be because you have a stock crankshaft damper, stock clutch, stock flywheel, stock everything else, and it's all balanced for that, right? So the problem will occur at that RPM because of all the stock stuff. If you change a number of those components, that may necessarily change where the second harmonic of the crankshaft occurs, okay? So if you lighten the flywheel by 10 pounds, or if you change the crankshaft damper, or if you do something else, it will change where the harmonic occurs. But basically the second harmonic on street cars is the destructive one, and S52 cranks suffer that the most at 7,400 RPMs. You can get an ATI damper or other custom dampers on the crankshaft snout to combat those RPM torsional vibrations and basically help make it live at higher RPM longer. But it's kind of a losing game on those cranks. So there's a number of other cranks you can run on these things. The S52 is the 3.2 liter, so it's the longest stroke and the most problematic. The S50, the 3 liter, is a little bit less stroke. That's the one I run in my sedan currently. And those have been known to rev to 8,000 RPMs, okay, no problem. It really depends how much you want to push it. The 2.8 cranks out of the M52s are known to be really, really good. And a lot of guys in Europe, specifically Sweden and Poland over there, run budget builds with 2.8 cranks. And they basically make a ton of horsepower and rev them to 8,000 RPMs all the time, and even in drift applications, and they seem to have really, really good success. So they're kind of the inspiration for my next coupe build, which is actually going to be an 8,000 RPM 2.8. But that's not this engine. This is Tyler's 2.5, which we're keeping it sane. It's probably going to be 7,000 RPMs because it has M50 Vanos valve train still. We're not going to upgrade that. That's going to be stock valve springs and retainers, which is only single because it's a Vanos engine. The non-Vanos has a dual valve spring here, which allows for a bunch more horsepower and torque and RPM without valve float. So that's beside the point here, I suppose. We've removed, let's get back to what I was talking about. That was a huge tangent about BMW 6-cylinder engines. I hope that was informative. It kind of needed to be said anyways. I don't know if I should make a separate video for it or not, but here are the parts we've removed currently. We've got the cams, the trays, the caps, Vanos unit, and then the cam gears, another cam gear, head bolts. So basically the head is pretty much ready to come off, except for there are a couple more Torx bolts. So there's some tiny Torx down here. There's one in the corner over here. And there's one that this is attached to down here. Basically, you have to remove those two. I'm pretty sure that's it beyond the other 14 head bolts. And then it should come up. It has two dowel pins, so one on the intake side somewhere over here, one on the exhaust side somewhere back there. So you kind of just have to wiggle it up off of those. And then we should have the head off this engine. So let's see if we can pull it off. Let's do it. Alrighty, I'm not exactly sure where I left off because I just went to the bathroom real quick, so we'll give you guys a recap of where we're at. Just pulled the head off, got all the stock EA12 Torx bolts out. Those are all going to go in the trash because we're getting ARP head studs, ARP 2000 10mm size, so stock size, but ARP 2000 material. That's what you need for these things. Cams, trays, everything looks perfect. The head has a bit of carbon built up. I mean, it's got some evidence of carbon and stuff. And like I showed earlier, the coolant port was quite nasty, so definitely cleaning that out will be good, and we'll make sure that Tyler changes his coolant quite often rather than the previous owner of this car or engine, whatever, not doing so, as evidenced by the corrosion in there. So let's see what else. Here we've got the short block of the M50TU. We are keeping the front timing cover on. We're probably going to keep the chain guides as is. Tyler was trying to do this like as cheaply as possible. So basically we're kind of gambling on some stuff. We're keeping the rotating assembly as is. We're keeping the chain guide as is. Chain is the same. Usually those things don't stretch that much unless you're just running the piss out of them on the limiter. But this engine actually came out of an automatic 325. So chances are this guy did not rev it very high and was just putting around all the time with this sound system. So most likely this chain is going to be fine. All the other stuff in the engine, in the head, has checked out really, really nicely. So I'm expecting that it's been treated fairly well. We are actually going to put it on an engine stand, flip it over, and check some rod bearings and main bearings just to make sure that everything looks 100% perfect, but we are optimistic. The only thing I worry about is, like, you know, this engine was from 1994, so it's 2020, it's 26 years old. And this is a piece of plastic in here that I don't even know if it's supposed to be detached like that. They may already be broken. I'm pretty sure it's not supposed to do that. So that may be a mandatory fix right there, in which you guys have to pull the crank pulley off and this front cover off. And Tyler would not be super happy about that because it adds a little bit of labor and stuff, but it's really not that bad. And he's coming from an M20 where he's had several built heads on there. and they've had various issues with timing belt or whatever else, and bending valves and just all sorts of shit, to where he just hasn't been able to drive consistently. And these things with 24 valve with the timing chain are very, very reliable. But when you do pull one apart and you're just like, even if you're doing an OEM plus refresh like we're doing right here, we're still doing ARP head studs, cut ring, oil pan baffles, welding the oil pump nut. Like, we're taking necessary precautions to make sure this thing actually lasts, because there's no point in doing all this work and then missing like one step, like welding the oil pump nut, you know, and then having an oil pressure loss and losing the whole motor. That's just stupid. So same kind of thing with chain guides like this. These just, they aren't very expensive. The only problem is, to get to that, you have to remove the upper timing cover, which means removing all of that stuff. It's not too bad, but it is something that may need to be done, because actually this one looks broken. It should not be coming off with a thing like that. When it has tension on it all the time, it's probably fine, but I think there's probably a plastic tab broken. Yeah, that one's broken right there. It should go under that edge and hold it on there and just clip in. And it is not there anymore. Maybe the other side's broken too. I still have one. I don't know. Either way, most likely this guide needs to be changed, which means this cover needs to come off. So that's another thing to deal with. The cylinder walls themselves look okay. I need to clean them up a bit, because the engine's been sitting outside for about 2 or 3 weeks. It previously was in a car that also had not been running for about 7 years. So it's been sitting a while, but everything should clean up just fine. This is all just surface stuff. Like, I could remove that with a sponge, basically. Just wipe it a little bit. But yeah, I'm not super worried about it. I'm going to, like I said, put it on a stand, pull the pan, check bearings. I'll probably spray a whole bunch of WD-40 in here, clean all this up, rotate it a bunch, just get the cylinder walls very nice and clean, and then flush the block out completely, because they're like, once I get the pan off, you can get access to like every single passage here, get all the flow through it you want, and clean that out at home. So given it's a budget build, I think that's the next steps. We'll get to it. But for now, we at least have the head off. That can go to the machine shop. They can pressure test it, make sure none of the valves are leaking or anything. We probably are gonna change valve seals, just because they're super cheap and there's no reason not to. And then leave all the valve springs and retainers and valves stock. That's just the easiest and cheapest thing to do for now. And yeah, and then also deck the head for the new cut ring head gasket. Here you can see it still has a stock head gasket on it, which is kind of stuck on there on the dowels. You can see this dowel here. There we go. So, stock gasket it does have fire rings in it, which is what you call these things. They're like some aluminum pieces to seal around the cylinders, which is smart, and that's basically the same design as the cut ring, except these pieces have cutting grooves in them that bite into the head, so they like just literally cut into the aluminum to seal Mega Boost. But all the other stuff is pretty much the same as the stock gasket. They have these pressure sealing silicone. You can see this little line around here. That's like, once you torque it down, that seals up. So same thing on the cut ring. It's a good design. So now we need to remove the valves and everything, and that way they can deck the head. Then we put all the valves and valve springs, everything back after they've been tested for spring pressure, make sure everything checks out, none of them are too weak. And then it will be pressure tested to make sure that there's no leakage at any of the valves. Right now it looks like all of them are fine. There's nothing obviously bent or anything like that. There's just quite a bit of dirt and corrosion and stuff from the engine sitting for so long. So we will take out these sensors, the coolant temp sensors, this hose that goes back to the throttle body loop, and maybe eventually we can get this thermostat out too, because it's so caked in there with bullshit. Change your coolant, people. Reminder number 2, change your coolant. Run coolant. Distilled water, not regular hose garden shit water. There's a reason you run distilled water and coolant, okay? It is anti-corrosive properties are important. Like, you can't just run regular tap water. Your shit will get fucked up like that. Alright guys, here's the wrap-up video for tonight. We have the head off, cams out, cam trays out, cam caps, all that stuff's off. We've inspected everything. Everything looks really, really good on the cam side of things, indicating that the oiling system has been good. There hasn't been a bunch of debris or anything, because you would see some evidence of damage on the cam journals or lobes. Something up there in the head, because that's the last thing to be oiled. But it all looks really, really good. So very happy about that. The head is off, like I said. The cylinder walls look a little bit dirty and rusty. That's because it's been sitting for 7 years and hasn't been run. Not too worried about that either. It's all very light surface stuff. We are going to be pulling the oil pan off and checking main bearings as well as rod bearings, just to make sure everything looks good. Tyler, like I've mentioned multiple times in this video, is trying to do a very budget build, so we're trying not to pull the rotating assembly out and have all that done at the machine shop. Typically, I would basically pull the engine all the way down, take absolutely everything out of it, have everything hot tanked at the machine shop, balanced, checked, you know, just blueprinted essentially. That's just typically the way I do things when I build an engine. So the last one I did for Jason was the same way. My own engine was the same way. And this one, it's just more of a budget build. So we're trying to basically keep all of the M50 Vanos rotating assembly in it without pulling that out and doing additional machine work. So we're going to clean up the block, or rather I'm going to clean up the block personally at home, and I'm just going to send the head off to the machine shop. They're going to deck it, pressure test it, change valve seals, and also check the valve spring pressure on all the valve springs, make sure none of them are like way out of spec or anything, because we don't want to have valve float or anything like that. We might possibly even shim the valve springs if needed. That's something we can do very easily with the equipment we have at the machine shop and the connections that we have there. Shout out to Dennis at Precision Engine Service / Dennis Murray Racing Engines in Austin, Texas. He is the man for basically anything you can think of. I don't want to name too many big shops, or rather any big shops that use him, but let's just say that he builds some 3,000 horsepower V10 stuff locally, and it's pretty impressive. So he knows his shit, and he's the one you want doing your machine work. If you can get in his line of Is Q line? What would you say, Q line? Yeah, basically, he's just got so much work that you are just gonna have to wait a bit to get your stuff done. Luckily, my family has a really good relationship with him. He's the man, and he really takes care of me. So I'm gonna see if he can deck this head for us, check the pressure on the valves and all that stuff, and usually I bought a torque plate years ago, which, if you're not familiar what a torque plate is, it's a big chunk of aluminum that you bolt on top of your block. And when you're having your boring and honing services done at the machine shop, you basically torque this torque plate to spec of your actual head, as it basically simulates your cylinder head being torqued on top of your block. So you have your block, so we have our block right here, right? We've got a block. The head's over there, but the torque plate is a piece of aluminum about this thick that you just bolt on top of it. and you torque it down at all the head stud locations as if it were a head. You just do the torque sequence, and then you go in the cylinders and bore them, hone them, do all of your work while it's torqued. The reason being, when you torque your cylinder heads really high, theoretically you can get some bore distortion. So the cylinders themselves are these cylindrical, based on the name obviously, tubes up and down in this casting of this iron block. Well, there's a head stud at each of the four corners, if you will, of the cylinders to hold the head gasket down and hold the head down and seal combustion, which is hundreds of PSI, if not thousands. So you want that to be sealed really well, so you kind of torque them to a high spec. Well, if you torque them too high, the bores themselves can actually move. They can kind of distort within the big piece of metal. You know, with all that heating, with all that pressure, like, metal can just move around. It's incredible. Some of the loads it takes, it just moves like a giant block of metal. You wouldn't expect it, but it can move. Luckily, E36 blocks are very strong. The iron ones, they do not have very much deflection. So we torque plated my personal drift engine to 120 foot-pounds on 11 millimeter L19 head studs. And if you know what an ARP L19 head stud is a very exotic material that you're not even supposed to handle with your hands, or it can corrode the stud itself. It has to be oiled at all times. There's all sorts of precautions with those head studs, but they are the baddest of the baddest shit that ARP makes. And I actually drilled my block out and have larger than stock head studs, and they're L19, and they're torqued to 120 foot-pounds. And at that kind of level, you want a torque plate on your shit because stuff starts moving around. And you can actually see at one point, I think I pulled my engine apart in 2015 or something because I had like an oil pump issue, or I just changed oil pumps and it had some debris in the oil pressure relief valve or something, and that blew crap into my engine. So I had to pull it apart and check it out and clean it out. And looking at the engine and at the bores on my engine at 120 foot-pounds on these 11 millimeter L19s, you could literally see within the circumference of the bore, where at the corners where the head studs were, the ring just wasn't touching. So you would see a wear, like a half moon, wear, nowhere, wear, nowhere where the stud is, wear, nowhere, wear again. So it was just the craziest thing, where basically the bore was pulling away at the corners because of how much clamp load was on it. And this is, keep in mind, an iron block, small bore, only 84.5 millimeters, one of the smallest bores you can run on these engines. The larger the bore, the bigger the problem, obviously, because less meat between the cylinder walls. But I'm running a very small bore for this exact reason, basically to run super high boost. And I've been doing that for about 10 years now. But I'm just letting you guys know that bore distortion is a real thing. If you torque your head studs high enough and get serious enough and you're trying to run like 30, 40, 50 pounds of boost, this is a real thing. So race teams very often torque plate their blocks. We're not doing that on this one. That was just an aside to why you do that and how that works. With a typical ARP 2000 head stud combo, which you run on these motors, you don't need to like drill them for larger threads or anything. They're 10 millimeter stock. I have 11, but 10s are fine. You just torque them to 90 foot-pounds. I think the spec is actually 75, but do 90. 85 at least, but 85 or 90. I did 90 on Jason Scott's motor, and that worked great. And then you also want to double check them after heat cycle and make sure they're still at 90. So my arm is getting really tired holding the phone out this far as like isometrics during quarantine right now, but I suppose I need the exercise because the gym's been closed for 2 weeks or something and I'm going crazy. All right, yeah, so I need to pull the torque converter off of Tyler's engine. The head's already off. I need to pull the valves and stuff out of it, and and then take it to the machine shop to be decked. I just need to actually double check with the machine shop tomorrow and see if they want me to pull the valves out first or if they want to pressure test it first. Because obviously they have to have the valves and valve springs and everything assembled to pressure test whether or not it can seal, right? The valve has to be in there with the spring. I'm pretty sure, maybe not actually. I don't know if they pressurize from the bottom side, in which case the spring and retainer and all that stuff wouldn't need to be in there, and they would just pressurize it and they would hold the valve up. I don't know. Either way, it needs a valve job, it needs a head decking, and we will be talking to the machine shop, aka Dennis Murray, aka Precision Engine Service, Dennis Murray Racing Engines, aka the inline six godfather. No, I don't know, I'll just say engine godfather. I don't know. Don't go to him though, because you're gonna clog up his fucking work queue and then I'm gonna have difficulty getting shit done, so never mind. Pretend it's ABC Engine Service. And yeah, that's gonna do it for today's video, I suppose. Hopefully I'll have one out tomorrow, or I'm at least gonna be filming one again tomorrow where I put the engine on an engine stand. I have one at the shop right now, but I need to pull a Ford 2.9 off it that's junk and then bring that here to my girlfriend's house. This is where I'm working on this stuff, and put that engine on the stand. I've got the hoist right behind me so I can lift it up easily, get the right bolts to bolt the block to it. And then I'm gonna pull the pan off, take a look at the bearings, pull the oil pump off as well to take it to Dennis over at Precision Engine Service again. He's gonna weld the oil pump nut to the gear. That way that thing won't have an issue on the limiter all the time, which is what it's gonna be used for, drifting. So, you know, if you're sitting on the limiter all the time, welding the oil pump nut is an absolute must-do thing. Let's see what else. So yeah, welding the oil pump nut, decking the head, pressure testing it. We're also going to do some oil pan baffles, and I talked to Tyler and realized that when you swap an M50, M5X, anything engine into an E30, they're naturally in E36s, they're rear sump, which means they pick up the oil from the back of the oil pan. And when they're in E30s, you have to convert them to front sump, which is how E34s are, the 5 series of that era, or of the mid-90s. So basically you can run an E34 oil pan on an E36 engine, and then it will fit in an E30 for a swap. But the oil pan baffle kits are different. So you essentially need a front sump oil pan baffle kit as opposed to a rear sump oil pan baffle kit. And personally, I really wish it were a rear sump setup, because rear sump is way better. When you're on throttle, all the oil sloshes to the back of the oil pan. That's just how it works on every car, just based on physics and G-forces. Like, that's just how it is. So when you're on throttle, it's going to the back. I would prefer the pickup to be at the back, you know? And E36s typically only starve when you're like track driving them and you have really sticky tires, and they starve on braking zones when you're not on power and the RPMs are coming down, and that's usually like kind of a best case scenario to starve versus high RPM on throttle, full load, maximum load on the bearings and everything. You really don't want it to starve in that scenario. So hopefully the front sump oil pan baffles will do the trick and he won't have any issues, and he'll be able to make his 400 wheel goal for a very, very modest budget of $2,500. Yeah, it may go over that slightly, but basically he told me, hey, I've got $2,500 to spend, you know, what can we do? And I told him, well, we can completely tear down the engine, blueprint everything, balance everything, torque plate everything, but still use stock rotating assembly and gap the rings larger, check bearings, all that stuff for about $3,700. Or we can just completely leave the bottom end stock, kind of homebrew, clean it up, get the head decked and stuff, weld the oil pump nut, do several other things, but basically minimize the machine work and minimize the labor a bit, and do it for about $1,000 less, or a little bit more. So So yeah, that's the current plan. We're gonna make 400 wheel horsepower with this 1994 BMW M50TU technical update, and it has 176,000 miles on it. So you've already seen the cams, the head, the cam trays, everything looks incredible. Shit, I guess tomorrow we're just gonna show you some bearings and some other stuff, and we'll get to it. Thank you guys so much for watching. Let me know in the comments below if you want to see anything specific on the engine, or if you want something explained in more detail, because like I said earlier, or in another clip of this video, I'm not really doing this for monetization or anything. I don't really have the time to continually upload YouTube videos, and I don't intend for that to be a thing necessarily in the foreseeable future. So I'm really only doing this for you guys to get benefit out of it. So if you enjoyed it, or if you learned something, please give me a thumbs up, please give me a comment. Both of those things help algorithms, and they will help this mean something essentially to a larger audience, rather than just being shown to like 100 or 200 people. If you just like it and then comment something, even if it's bogus, it actually helps the algorithms of YouTube. So you can just say hi, like, and it will literally boost me, and 10 times more people might be able to see it just because of that. So it's kind of stupid, but that's just how the world works these days with social media and digital marketing and all that stuff. So man, I look super tired. God, it is really late though. It's like 2 a.m. right now, but I've got bags under my eyes like crazy. I need some sleep. So anyways, thank you guys so much for watching, and I will continue with the bottom end teardown tomorrow. We'll look at the bearings. We will take the head to the machine shop, and what else? I don't know. I guess that's it. Stay tuned. See ya.